As always, this is part of a series of videos. Be sure to check out the annotation on the screen for the full playlist. I hope you have watched them because we are building on code that we've previously created as well as techniques we've looked at. Now, a few tutorials back, we used the trackball library to control the movement of the cameras with the mouse. But you can do it without that library, just using some basic math. Now, we're not going to get into using the mouse, but we're going to do a basic, basically the camera doing a 360, spinning around looking at our grid. So we made this grid last week. Let's go ahead and look at the code. And I've moved the code into a file called basic camera spin. And what we're going to do here is we're going to go down to our render function and make some changes here. In reality, we could put this, I was going to put this in the render function, and in fact I'm going to do it because that's the way I've done it when I practiced this. But we're also going to make an animate function. This stuff could also go in the animate function. But since every time you render, the camera's going to move, I guess render is a good place to have it. In the example code on the Three.JS website, that's where they have it, but that doesn't mean it's the only place it could go. But anyway, in our render function, we're going to create a variable, we'll call it timer. And what this is going to do, again, if you've done any type of gaming game development, or if you've watched my old tutorials on Python's Pygame, you know that we've talked about limiting the number of frames is what we did in Python in the Pygame by creating a clock and setting ticks to prevent it from running for more than 30 frames a second or 60 frames a second. And what this does is it just keeps things consistent in speed, where if you've ever tried to play like an old DOS game on a newer computer, some of the old games you can't play because they go super fast because they just let those programs run as fast as the computer could run, and they just didn't think about computers getting as fast as they are nowadays. So using some sort of time or clock function to time the stuff in your games or 3D renders will help keep it consistent and prevent that from happening. Now, it may run slow or jerky, but you're not going to get to where it runs so fast in 10 or 20 years when computers are faster that it's unusable. But we're going to use the date function. We're going to get now. And then we're going to take that value and we're going to multiply it by 0.0005. Again, you can play with these numbers and see how it affects the script. I didn't come up with that. Once again, this is from the documentation and examples on the Three.JS website. But what we're going to use now is we are going to say camera. That's our camera object, which we've already created. And we're going to adjust its position for its x-axis. And we're going to say use math and dot cos timer, which is what we just grabbed above the variable, which is the now time multiplied by a very small fraction. And then we're going to multiply that by 10. And we're not multiplying the timer by it, we're multiplying the costs. And I'm sorry, it's been a long time since I've been in geometry. I'm just following documentation. I can't remember what cost stands for. I'm assuming it's some sort of curve measurements. Yeah, I'm going to stop talking about that. Just trust me, this works based on the documentation. If you're more into math, it's been 15 years since I've been in school, and I was really good in math, but I didn't pay much attention either, so forgive me. But we're going to do the same thing here, but for the z-axis. Instead of getting the cost, we're getting the sin, which I do know from working with synthesizers. I'm assuming maybe that's the curvature of a wave, or in this case, the curvature of the camera. I don't know. Once again, I'm going to stop talking. Now, again, when we created the camera up above, we told it to look at the scene position, which would be, in this case, 0, 0, 0, because we're looking at the center of the scene. Well, if we don't keep updating that, as the camera moves, it's going to get off-centered. So if we want to look directly at the center of our scene, or another object at some point, we're going to say the camera, not the camera position, the camera look at, just as we did in a previous tutorial and is up above in the script, we're going to say look at the scene dot, or comma, sorry, yes, dot position. So getting the scene position, which the coordinates of the scene, which will be 0, 0, 0. And again, if you had other objects, you can have it look at an object. So basically, this is going to create the camera slowly spinning and looking at the scene. But if we save this and go back here and refresh, nothing happens because we need to make it so that it continuously animates it. So what we're going to do is we're going to create another function, and we're going to call it function animate. And we've done this in previous tutorials. And there's going to be two things in here. We're going to say request animation frame animate. So basically it's calling itself. It's basically creating a loop that's calling itself. It's going to go, let's animate, let's animate, let's animate. Get a new frame, get a new frame, get a new frame. But each time it does that, we also want it to run our render down here. Still, if we ran the script, nothing would change because we haven't called the animate function yet. So we can come up here, and after we initialize our script, we can just call the animate function. So basically our code is going to first run our initial function here, which does call render once. It doesn't really matter. That's going to bypass. That's going to happen, and then the next frame is going to be called. So we don't even really need that here, but it doesn't hurt to have it. We're also telling the camera to look at the scene, which once again is going to happen so fast in the renderer. It's not even. We could remove those two lines. It's not going to make a difference visually to anybody. But if I hit F5 now, you can see we're looking down at the scene and rotating. Now we're kind of high above the scene, and that's because of our Y position of our camera. So what I'm going to do is here, we've set the X, Y, and Z coordinates, and both X and Z are going to be overridden pretty fast. So we could just set the Y position, but it doesn't matter. I'm going to go ahead and set this to 4. That will put the camera a little closer to the grid. Oh, yeah, not 4, 4, 4, 4. Just 4, please. There we go. So now we're down on it, and we're spinning. Let's go ahead and try a different value. Again, I recommend downloading this code. It will be a link in the description to all the code in this series, and playing with the numbers and seeing how they affect the code. So there we go. We've got a spinning camera using just the minimal library from Three.JS and a little bit of math. So if you wanted to spin around the scene, or if there was an object in the scene, you want to spin the camera around it, it will do this forever. Let me scroll down here, and let's try, I haven't played around with this, let's go ahead and try changing some of these numbers. Let's go ahead and change this to 0.0015, see how that affects the camera. You can see we're moving a lot faster now. So you can change the speed of the rotation by affecting this number here, making it, if we want to go slower, a smaller number. Or if we want to go higher, we can go a higher number. Again, we can adjust the camera position, either the Y up here, or we could probably affect the Z and the X here as well. But go ahead, download that code, play with it. So very simple. Basically what we've done today that's new is we've added to our render function a thing that grabs the date and time and multiplies it by a fraction, which is kind of like dividing. And then we're going to affect the camera position, the X and Z position, and do some math with that timer that we just created, and make sure that every time we move the camera, we reposition it so it's pointing at the center of our scene. We also added an animate function that basically gets us new frames and renders out those frames, and then we made sure that we added in this animate. We called the animate function so it actually runs. So as always, I will upload this code to my website. There should be a link in the description to all the codes from this series. You can view them there. Again, Most of our videos so far we're using WebGL, which has some benefits on a lot of systems as far as system resources and using using hardware acceleration. But a lot of this is very simple. Switch it over to using a canvas, which we will do in the future, and that will, in some cases, make it not run as smooth, but make it more compatible at the current time. Hopefully, as time goes on, more browsers and more hardware will support WebGL. But if not, there's also ways with the Three.JS library to have it detect whether you know whether it should use Canvas or WebGL, which is something we'll probably get into in a future tutorial. I haven't played with that too much. I've just read over it. I haven't actually given it a try. As always, be sure to check out the Three.JS website, threejs.org. That's THREE dot or js.org. And also visit my website, filmsbykris.com. That's Kris with a K. There should be a link in the description. Also, while you're there, you can search through all my other videos. I currently have around 1,500 videos. You can also get a link to my IRC channel there on Freenode, which is #filmsbykris. Once again, Kris with a K, which is a great place to come and chat with me and other people and ask questions. Below, you can comment. Comments are a great place to put comments, the comment section, but not necessarily the best place to ask questions. Also, if you're enjoying this topic of Three stuff, with HTML5 and Three.JS, be sure to like this video so that I know you like it, and be sure to subscribe so you don't miss any of my videos. And as always, I hope that you have a great day.